Probably 99% of the nodes you will see in PrecisionTree are green square decision nodes, red circle chance nodes, or blue triangle end nodes. However, if you open the PrecisionTree Node Settings dialog box, you see two other possibilities. Purple square logic nodes and gray diamond reference nodes. This video will briefly discuss each of these. Recall that when you have a decision node, the branch followed is determined by your optimality criterion, usually maximum expected value. The corresponding branch gets a true label, indicating that it is best. A logic node is different. The branch that gets the true label is the one that satisfies a logical condition that you set up. For example, this might be a policy constraint from management that has to be followed, regardless of its effect on expected value. The example you see here, one of the PrecisionTree example files, illustrates logic nodes. The company's decision is whether to prepare a bid at cost $8,000. If it does, it will then see how many man-hours are required to complete a project: 800, 1200, 1600, or 2000. The company's rule is to use contractor A if the required man-hours is less than 1500, this cutoff point, and to use contractor B otherwise. Perhaps this is because contractor B has more capacity, but regardless of the reason, it is the company's policy. Then the company's revenues from using the two contractors are shown here. The model at this point has 3 of the 4 required logic nodes: here, here, and here. And I will illustrate how to create the last one here. First, click the End node for the 2000 branch to add a node in the usual way. Choose Logic, choose the name, change that if you like, and name the branches. And click OK for now. Now there is a new logic node with 2 branches. Then right-click the new node, select Node Settings, select the Branches tab, and enter logic and value formulas, as shown here. The inequalities in the logic column indicate which branch will be followed. They reference the cutoff point and the number of hours required, D26. The formulas in the value column indicate the associated revenues. Click OK. You now see that the contractor B branch has the true label. This is because there are now 2,000 man-hours, and according to company policy, this requires contractor B to be used. You can also see the formula, 50,000 minus 20 times D26, below the contractor B branch. That's the same formula you entered in the dialog box. Note that the required man-hours are listed under the corresponding chance branches. These values were used for reference in the logic formula, but they aren't part of the payoffs for the tree. If you wonder how this works, it is because of the calculation option chosen for the model. As you can see in the Model Settings dialog box, the payoff formula method has been used, and the formula says to add the values on the Submit Proposal and the Logic branches. The values on the man-hours required branches are ignored in terms of payoff calculations. The second new type of node, a reference node, is intended for very special cases where you have a subtree that will be repeated several places in the overall decision tree. However, each instance of this subtree has to be exactly the same: structure, values, and probabilities. The example you see here can be used to illustrate reference nodes. The decision branches have different costs, and the two chance 1 nodes have different values and probabilities. But we assume that the chance 2 node and its branches will be repeated exactly as is in each of the 3 end nodes below it. You could copy this subtree and paste it 3 times, but this would increase the size of the tree. Instead, 3 end nodes can be made reference nodes, each referencing the chance 2 subtree. To do this, click any of the end nodes and fill out the Node Settings dialog box as shown here. You choose the Reference option and have it reference a node in the tree. When you do this to each of the 3 end nodes, the tree looks as you see here. The vertical lines indicate how these diamond nodes reference the chance node above. If you wanted to verify that this is working correctly, you can change the bottom reference node, say, back to an end node, and then copy the top subtree and paste it. You will see that the expected value is the 13,600 shown here. I'll verify that. I'll make it an end node. I'll copy this subtree, paste it, and there is the 13,600 expected value. Again, the main purpose of reference nodes is to save space, so that the resulting tree is more compact. But remember that the subtree being referenced must be an exact replica of the desired subtree for the reference node. If its values or probabilities are not the same in each case, a reference node can't be used.